Okay, is that sounding better?
Yes.
Yeah, that's a lot better.
Okay, good, good, good. So just know when I post this video, there'll be a part A and a part B because it will truncate the recording. Okay, so let's share our screen. We'll go back over there. So we lost the work, but so that's, I like to do it separately in like a step 1, figure out the water, and a step 2, figure out the metal or the lead. They have it consolidated into one thing. There's just a lot of variables there. There's definitely a chance of missing something or losing something. So let's work on one of these problems, or I'll have you all work on one of these problems and then we will go over it. Okay, so if 38.000 grams of a hot metal at 130 degrees C is poured metal. Okay, so if 38.00 grams of a hot metal at 130 degrees C is poured into a calorimeter containing 85 grams of water, what is the specific heat of the metal if the water rises from 22 degrees Celsius to 28 degrees Celsius? So same identical setup to the last thing we looked at. Think of the styrofoam cup. We've got the water stuff, and then we've got the metal stuff. I'll give you all till about 1:30 to about 5-7 minutes.
Do we wait to reduce to significant figures till the end? Should we like be as accurate as possible?
Yeah, I would do that. Yeah, I'd wait until the end. Okay, so In this one, we're gonna start by figuring out how much heat or energy the water gained. So the Q of H2O is gonna be equal to the mass of the water, which we said was 85 grams, times the specific heat, which is 4.184 joules per gram degree Celsius. If you're using 4.18, that's fine. And then our change in temperature, which is our final minus our initial, so 6 degrees. I'm gonna make this 0.0 and 0.0, so I can have at least two sig figs, so 0.0 degrees Celsius. So the C's will cancel, the G's will cancel. Okay, so our Q of water will be equal to 2,134 joules roughly. That means that our Q of metal should be equal to the negative value of that, negative 2,134 joules. So what is the specific heat of the metal? So we want to find C of the metal, the specific heat of the metal, which is going to equal my Q over my M times my delta T. I know my Q is this negative 2,134 joules. My mass is 38.00 grams. And then my change in temperature is, this is the final. So we assume the 28 is talking about the water and the metal together. So we have 28 minus my original, which is the 130. We have a change of negative 102 degrees Celsius. None of the units will cancel, that's fine. We don't want any of the units to cancel. So 2. All right, I got a Q of 0.55 joules per gram degree Celsius. I had 2 sig figs here, which would mean that I would only honor 2 sig figs here, so I could only honor 2 sig figs there. Is that what y'all got? Where did the 102 come from? So the 102 is the change in temperature, right? We've got a delta T here. My change in temperature is delta T is always going to be T final minus T initial. Okay. What was the final temperature of the metal? 28 degrees Celsius. What was the initial temperature of the metal? 130 degrees Celsius, 130 degrees Celsius. Those two subtracted by each other is negative 102 degrees Celsius. So when you're dealing with the metal, it's getting colder, so it's losing energy, and its change in temperature would actually be a negative value as well. So those negative values will cancel out. Emma, does that make sense? Cool. Okay. Any other questions about
problems like this where we are going to have to do conversions?
As far as like if I gave it to you in kilograms or something?
Yeah, kilograms, or like you would never use anything other than Celsius, right?
I mean, you could see it in Fahrenheit and you'd have to convert it to Celsius. That is a possibility. Yeah, I wouldn't say that that's not an option. Or it could be in kilograms instead of grams, so you got to convert it into grams. Okay. Yeah, so always looking for those little details, but as long as your units, you're converting so your units match with that joule per gram degree C, you'll be good. Okay, just make sure everything gets into those units. Okay, so this is sort of technique 1. This is a calorimeter where we have water and a metal. We're going to do 2 more different things. One, we're going to do water with a solution, and then we're also going to do water in dissolution. But we're not going to do those today. I don't want to start those today. So we will stop there. Next week we have a hopeful week to continue to work with thermochemistry. So we'll lecture and then we'll do some more review. Let me know if you have any questions. If you don't, have a good weekend, and I will see you guys on Tuesday. Bye. If you do have a question, feel free to stay around. I'll be here.